Okay, friends, good morning, good afternoon, good evening to everybody. So today we will be talking on the recent trends in geoinformatics, and you might have heard in our earlier lectures on the concepts of GIS and how this particular technology is being used everywhere. And here it's not possible for me to cover all the aspects of geoinformatics, but I thought that I can at least pick up few areas where a lot of development is going on. And if you see the present era, this technology has been utilized up to its maximum potential. So there are many applications wherein this technology has been used and utilized. And in fact, I'll be covering few areas where I think that it might help in to certain extent. Uh, Overall lecture, if you see, I'll be talking about 3D city modeling, which is also quite important with respect to many projects which are undergone in various parts of the world. How this particular technology can provide you those 3D models in order to develop certain type of applications. I'll talk about GeoWeb services. Which is an area where you can utilize all the data sets available, especially the geospatial data sets. It can be consumed and you can develop different type of applications. Uh, there is also a lot of development which is taking place with respect to the open platforms. I think many of you are aware of Google Earth Engine, as well as some initiatives on geospatial data cubes. Then I will touch upon some concepts on citizen science, wherein a lot of applications, and in fact, you might have observed that this citizen science approach has been used, especially during pandemic time, where a lot of different like field data was collected with the help of this technology. I will also talk about geohealth because this area is coming up quite frequently, especially because of the pandemic situation. A lot of development has taken place in this area, and there are many initiatives which have been taken, especially in India as well as abroad, that how you can make use of the geospatial data for health applications. Big data, I think I will not touch more on big data part because I think my colleagues have already touched upon some of the concepts of big data. So I will quickly glance on the concept of big data. And then one detailed use case I'll be sharing with you, that is the Indian Bioresource Information Network, which is a new application which we have developed recently, and very soon it will be available in the public domain. And then, of course, we have open source softwares and also how the overall the overall evolution which has taken place in the field of geoinformatics. So this is overall content which I'll be talking about in detail, and hopefully you will appreciate that how this technology is penetrating in almost all the areas of applications, whether you talk about disaster, whether you talk about natural resource management, whether you talk about business analytics, whether you talk about governance. I think almost all areas are using this technology. So, when we talk about geoinformatics, or let us say geospatial technology as a whole, it caters to all components like GIS. Anyway, you are much aware of it. Then you have GNSS, wherein you try to collect the information by making use of global navigation satellite system, where you have the constellation of satellites, and they provides you the locational information which can be used for different applications. Earth observation is, I think, you are much aware of that a lot of satellite data is available through this domain. And then we have scanning also, that is LiDAR or laser data or even radar data. All these different type of data sets is being provided. So overall, when we very specifically when we talk about this technology, especially the Earth observation, I think it caters to the major part of the geospatial technology, because this takes the snapshot of the given area by through the satellites, or you can even make use of these the aerial surveys, or one can even think of UAVs and all. So there are a lot of data sets which are coming out, and they provide the geospatial information. And in fact, there is a lot of geophysical products which people are trying to derive from those data sets, and those geophysical products or any derived products can directly be used for different type of applications. So I think I request each one of you to kindly switch off your this videos. I think videos, most of you have disconnected. So I think because the network speed is not very good, so so I request each one of you. But I am audible to you? Am I audible to you? Hello? Yeah. Okay. Okay. Fine. Now, GIS, as I told you that in my first class, also I have told you that GIS has it takes all the data sets, it integrates all the data sets together and provide you some knowledge information or hidden information, which can ultimately provide you a lot of decision-making outputs. So GIS, GPS, ground data, everything together can help you in coming out with a different type of application. Now, coming to the 3D, I think this is an important area where the people are trying to create the 3D city models. In fact, let me tell you that in the earlier times, when if you talk about, let us say, 10 years back, or even beyond that, people were using the 3D models only for the visualization. But over a period of time, because of the development with respect to the data standards, with respect to data interoperability, a lot of new frameworks, or let us say models, have been developed. Like OGC has come up with a city GML model, which basically takes care of both the semantic as well as the geometric properties of the data. So why it is in fact it is important to have those 3D city models? The reason is that it's not only meant for the visualization, but rather it can even be used for various new applications can be derived. Like you can query them. You can query a 3D city, 3D data. You can apply any type of analysis to those data sets. So that is the potential of a 3D city model. So it's not limited to a geometric domain, but it has also got a semantic information which can really provide you a gamut of information. In fact, if you look at the earlier times, or even the industries who are dealing with the design of the different type of building, they are making use of BIM models, that is building information models, which provides the like you can make use of Google SketchUp, or even you have there are so many other city engine is there. So many different softwares are there by which you can create those building information models, and they are in fact quite good in order to provide holistic information about this building. So just look at this particular 3D city model, wherein this particular model, or let us say building, can be utilized for various purposes. Like it can be used for estimating how much solar potential can be estimated. This can even be think about that how the 3D cadastral mapping can be done, because if you look at in most of the countries, you are only limited to 2D cadastral, but you really have to make use of 3D cadastrals because you have a lot of floor information and it is not possible for you to depict those information on a 2D maps. So 3D cadastral is also an important area. You can even think about the indoor navigation. You can think about the noise propagation. You can think about the utility mapping. You can think about the emergency responses, visibility analysis. I think there are so many applications one can think of in getting that information. But when we talk about 3D city models, you have to really see that up to what level of information you will be providing to the user. So it all depends upon what level of detail will be captured by the user, or the requirement by the user. Like for instance, here you can see that there are 4 type of level of details which are provided by OGC CityGML. Like LOD0 means LOD level of detail, where you only need a footprint of a building. If you really want to have a little bit more information, you can have a building or a block model or a prismatic model of the building that can be called as LOD1. Similarly, if you are looking for a model where you only want to have some information related to the roof structure, that can also be captured by making use of LOD2. LOD3 basically talks about more detailed information with respect to the outer or let us say exterior information, like the type of windows, what is the texture of the windows, how the facade, the overall how it looks like, and it covers to roof structure as well. But when you talk about LOD4, this is much more detailed information where you are trying to capture the inside information, especially for the indoor navigation. People are making use of level of detail 4, where the interior structures are captured and one can use it for different modeling purposes. So this is a general taxonomy of a 3D use cases. You can make use of 3D city models where, like I was talking about 3 different type of applications wherein different type of 3D models can be used. Like if you have a geometric model, you can use it for estimation of the shadow, like in which area there will be shadow, or even you can think about that how much sun how much area can be exposed to the sunlight. So those type of application where only the geometry is an important aspect, that can be taken care. But there are 3D city models where you not only need geometry, but also you look for the semantic information wherein you have more detailed, like how many floors are there, the number of windows, number of doors, all those things carries to the semantic information. As if you are looking for both geometrical and the semantic information, like you can work on the estimation of solar potential, that how much solar potential I can generate from a building. Similarly, the last point is more towards the noise. Like for instance, if you are looking for geometry, you are looking for semantic, but also you need some additional information, like something which you have collected in the field, that can also be captured. So that is more of an external data, which is like you have geometry, you have semantic, and then you have the external data. So the example is like noise emission calculation, like you are looking for those type of information. So these are because of their different type of 3D city models, which provides information with respect to geometry, semantic, and also some external data can be added. So there is a in fact, OGC Open Geospatial Consortium, which consists of more than 500 to 600 stakeholders who are involved in the development of Open Geospatial Consortium, where interoperability and standards is the main objective. And there, in fact, they There are many models which have been developed, like 3D city models, but nobody is providing because they are more industry specific and they don't share most of their data model. Like if you talk about Google SketchUp, they have a Collada model. Similarly, City Engine is having a different type of models. But when you bring them into City GML, then the data is open, data model is open, and you are able to store those data sets into the RDBMS, and you can really work on the semantic information. So here you can see that the 3D city models within City GML not only provides the geometry, it provides semantic, it provides appearance, as well as it provides the topology. So all the data types are covered into City GML, and in fact, it provides a mechanism of integrating the data and ultimately developing those applications. So this is a classic example of the solar energy estimation, like solar potential. And this is our department, Geoinformatics department at IIRS. In fact, we try to develop that how we can ultimately provide these type of that how much solar potential can be estimated by making use of this technology. So we have taken a high resolution data of a given area, of this particular area, and then we have taken the footprint from the high resolution data, that is our Indian Cartosat data, and from there we developed the model by making use of Google's SketchUp, and from that model we converted that model into a City GML, or let us say a semantic model, where you can see the walls, windows, everything is separated. And once they get into the City GML, you are able to put them into a different RDBMS and apply these type of operations. Like here, I think there is some the animation is not working. So here we have tried to see that how along the equinox angle, how much solar energy can be harvested. So here you can see that these type of calculations, or let us say analysis, can be carried out by making use of City Engine. Now here there is another application. I think I'm unable to show you the animation because it is totally animated. So let us okay, now here I can show you some level of animation. So here this talks about the noise emission, and here what we did is we have created those 3D city models by making use of terrestrial laser scanners. And once the terrestrial laser scanners, those models was created, then we try to estimate the noise emissions by taking different measurements at different cross sections. So here we have used the noise recorder to get the noise decibels along different timings, and also what we did is we have also added different coefficients for two-wheeler, three-wheeler, four-wheelers, different type of vehicles, how much noise emission they do, and this type of mathematical calculations are there cases of, I think there is some question from our people. Let me see what is the question. Yes, are there case of study that refers to the use of 3D city model for cadastral purposes? I think for the cadastral purposes, I think there is not too much study, because I was talking about the 3D cadastral, that itself it is in the verge of pilot studies. You might get few papers on the 3D cadastral, but if you talk about the implementation stage, because see, when we talk about the 3D city models for the entire region or a big region, you need to have the lidar measurements, because you cannot this is a small cross section which I have done it by making use of terrestrial laser scanners. But when you talk about a big area where you really have to keep those information of all the buildings, you have to rely on a very high resolution lidar data. And if you have the lidar data of of a given area, then of course these 3D cadastrals can be developed. So there are, you can search it, Google it about the case studies on the for the cadastral purposes. But this we are working on this particular area, that how the 3D cadastrals can overcome a lot of limitations which people are encountering in the 2D maps. So one can explore these things. So I think I don't know to what extent I have answered your question, but the case studies are really limited. Okay, so now here, if you look at this particular for the noise emission, so I was talking that we have for different type of vehicles, we have derived the coefficients, and once the coefficients were derived, we made them into a form of an equation, which you can see on the left hand side, and this simulation we could do it. So this type of now here even we made a curve, and we have what we have done is we found that at some point of time, like maybe at 7 o'clock, the decibel level is very high, evening 7 o'clock. So so these type of if these type of information can be communicated to the decision making, then you can like you can see that redness is very high at 7 o'clock, even it reaches to 70 decibels. So these type of information, once you create this information, they can directly be communicated, and one can really make it in a real time mode. So this is a classic example of how the entire. Now here I would like to tell you something on the indoor logistics, because the indoor navigation is always in fact a requirement for most of the I think most of the people need these type of 3D models. So the indoor models. So let me show you once more. Yeah. So here this is I think Taj Mahal, 7 wonders of the world, and here it is not only the outer exterior which can be captured, but one can even go for the indoor navigation, because these indoor navigation has got a lot of advantages. It not only captures the indoor utilities, but also it can be used for different type of application. Like if you go to shopping malls, or if you go to so many other, so indoor routing is also very important, because you may not get the GPS signals. So you can either make use of Wi-Fi signals, or you can make use of different mechanism by which you can communicate in that. Now these type of this 3D city models can be developed for the World Heritage sites, and in fact in India we have tried to develop these type of models so that we are able to visualize this data for various purposes. So indoor mapping can have a lot of applications, like indoor mapping is one, indoor positioning is there, indoor location is there, indoor routing is there, indoor asset tracking. So many applications one can visualize by making. And this is our department on top. You can see that our department, how you can. So these are some of the examples that how the indoor logistics has an important information. Now I will jump to the another area. So 3D is, I think you might have understood that how the 3D information is being, especially for the smart city planning, this 3D city models can really be helpful. Now you might have heard the lecture on web GIS and all. In fact, GIS data is whatever data you are producing has to be in the public domain. Public domain in the sense that anybody who would like to basically visualize your data, would like to overlay your data, and would also like to I would say consume your services for their requirements. So most of the data what you see in the global especially I'm talking about the GIS data, they are in the form of services. So services, why it is important? Because when you have the services, it can be shared, it can be consumed, and ultimately it can be used for various applications. So I think the most important part of GIS, or let us say distributed GIS, or let us say the web GIS, everywhere you need to have the data in the form of services. But how you can achieve those services? So that services can only be achieved if you are making use of the standards. Now, when we talk about standards, see, whatever data what you produce, if you don't make it interoperable to each other, then it is of no use. So in order to make it interoperable among the various information systems, or let us say among various data providers, you have to follow an interoperability. So I will tell you the interoperability, but the most important thing is when you have this interoperability, then the sharing of the data is possible. So when I say sharing of the data is possible, means that you can allow the two information systems to communicate with each other if they are sharing their metadata seamlessly, if they are sharing their processes seamlessly, and if they are sharing their information seamlessly. If that is possible, then it means you have attained the interoperability. And interoperability can only be accessed if you are making use of the standards. So OGC provides certain standards, and if you follow those standards, then it is possible for you to make your data interoperable so that it can be used by everybody. So if somebody follows the standards like OGC standards, then you either make you make WMS services, WPS, WCS, all those. When you talk about OGC services, you have to make you ensure that your services are interoperable and they can be used without any hindrance. So ISO OGC is one of the most important agency, or let us say consortium, which takes care of the interoperability. So here you can see that how from the flat file model, how it has moved to network, then DBMS, and then we have the web services. Now, what happened that many countries, they are trying to create the spatial data infrastructure for data sharing, and that is only possible if you have all the data in the form of services. So these type of SDI frameworks people are creating, and in fact, there are a lot of open source softwares which provides the development of those SDIs. Like for instance, GeoNetwork is one of the open source which was developed under the initiative of the FAO, and in fact, this application can allow you to create the network of information. So basically, if there are so many data providers, they can provide the data in the form of services, and these services can be accessed through an SDI framework. So SDI is basically it provides a catalog of services which is being provided by different data providers. So this is the beauty of creating the SDI portals for the data sharing. Now here, I would also like to inform you that people are not only creating the SDI portals, they are also trying to develop the decision support system. Now, this decision support system basically has got a lot of advantages because it basically takes care of different type of decision making. I would say it enable a decision maker to take the decision, because here in the decision support system you have all the data sets available, you have all the information available, you can apply different type of models on a DSS, whether you talk about multi-criteria decision making, which might be AHP based, or you can have different type of mechanism. And if you have these different type of multi-criterias, you can apply on a decision support system, and ultimately it can be developed for a particular application. So DSS can be developed for forest related applications, DSS can be developed for water resources, for agriculture. There are so many applications which one can directly create once these type of decision support system. So these DSS ultimately can provide you a very specific information which can be used by a decision maker. Now, I think you might be aware that there is a lot of satellite data is being created, and you can see there are so many satellites which are providing the voluminous data, irrespective of, like, if you see over here, there are so many satellites which are launched by different space agencies all across the globe. There are commercial satellites. There are even so many other missions, LEO, GEO, or different type of missions are there. So a lot of data is coming, and in fact, there is an explosion of EO data, and there should be a mechanism by which a user is able to make use of those data sets. There are two aspects. One is I should able to select the data. I should able to pre-process the data. I should able to create my own application, and ultimately I can deliver it. So these, if I have to do all those things without making use of the platforms, it is really difficult. So for that, there are concepts of data cubes which is now coming up. There is a data cube developed by AGDC, Australian Geospatial Data Cube. In fact, they developed the data cube where they are trying to integrate all the satellite data of a given area. Like suppose they have developed it for the entire Australia, and they have all the satellite data of the Landsat. The entire temporal data is embedded into it, and even it's not only the temporal, all the dimensions of the data can be collated into it, and the user can directly access the data cubes. And in fact, the beauty of the data cubes is they provide analysis ready data. So when I say analysis ready data, means you don't have to pre-process the data. Already some level of pre-processing is being done. You only have to extract the information, and once you extract that information, you are able to apply the different type of algorithms to those data. So the preliminary part of searching the data, applying a pre-processing can directly be taken care by the data cubes. And once you have the analysis ready data or ARD data, you can make use of. So these type of data cubes will be a very important breakthrough in the space domain, especially for the remote sensing data sets. So we have also created some level of data cubes where we wanted to we demonstrated this for our only small pilot study was carried out just to see that how we can create these type of data cubes for various purposes. So I think in the coming time you will see that a lot of plugins will be available through the open source software, and you can access directly the services from those data sets, and you can take the area of interest and you can apply those type of small applications. So there are some public players like Australian Data Cube, and then NASA Earth Exchange is there, ESA Cloud Toolbox is there, and there is a lot of I think development by the private sector. You might be aware about the Google Earth Engine. I think they are providing one of the best platform available for the user, because and in fact they have they have a good catalog where Landsat data, Sentinel, MODIS, lot of different type of layers are available. User only have to take out those the area of interest, apply the operation. You can apply, because you don't need, they are all cloud-based platform. There is no dependency on your standalone system. You only have to access this Earth Engine, and once you access those Earth Engine, you can really apply this thing. And once you apply these data sets on these you apply your operations, you can directly take out the outputs and which can be used. So the turnaround time in developing an application, going with the indenting the data, pre-processing the data, applying the operation, that entire time which you were spending in the earlier time is now very limited, and now you can do all these operations by making use of this open platform like Google Earth Engine. And in fact, they are providing the APIs to develop new applications. So I think this is the USP of the Google Earth Engine, where you have the most important part of the Google Earth Engine. They have a good archive of the data for the entire, like you might have seen time lapse of the Google Earth Engine, where the around the entire historical data can be browsed directly on those on your directly web platform. So these type of the cloud-based geospatial data processing for executing large-scale data analysis using Google Earth Engine is one of the classic example. Then there are like, for instance, applications developed by on a GE platform like Map of Life is there. Even there is a global surface water application. There are so many different type of applications which can be built directly on a Google Earth Engine. So that way, it is really the handling of the data is simple. You are not dependent on your hardware resources. You can directly make use of these cloud platforms, and the turnaround time is very less as compared to any other application. Another thing which is quite important is the data warehouses and OLAP. You might have seen a lot of analytics which is being provided in most of the WebGIS applications, and they are totally dependent on a concept called OLAP, that is online analytical processing, where you are storing all the data into RDBMS. You can see there is a conceptual data cube which can be created, and it's not the satellite data I'm talking about. I'm only talking about a simple the database, a simple RDBMS which can be stored by making use of these OLAP concepts, and you can apply a drill down operation in order to harvest the information. So these type of OLAP, the data can be organized in the form of data warehouse, and you can extract the information. So these type of OLAP operations can really provide you more detailed information. That is, when you slice the information, you have more and more in data which can come out from this, because you cannot store these data in a 2D table. You need to have a conceptual 3D table. So for these type of studies, people are making use of star schema, where you can directly link different entities and you can extract those operations. Now I will come to the any question you have in between. Do you have any question, or you are understanding it, or maybe if you can message, I think it would be good. No means I have not understood. What do you mean by no? No question?
I have no.
Yes. Alexandra.
Yes, I hear you.
Yeah. No questions?
No, thanks.
Okay. You are able to understand?
Yes, of course.
Okay. Okay, if there is no question, then we will further move with the concept of citizen science. This is, I think, it's an important area. Reason is that you have to collect the information. Collect means it's not possible for you to capture the real-time information. Like through satellite data, you are capturing the overall landscape of a given area. But if you really want to capture some information with respect to, let us say, there are so many projects. You might have heard about GBIF, global biodiversity infrastructure, eBird is there. So many different type of applications are, especially during COVID, a lot of citizen science application was used. So basically, these application is more inclined towards the involvement of public, wherein you can provide lot of information for a given project. So basically, citizen scientists are more, they are considered to be a volunteers who contribute their time, effort, and resources toward scientific research. And in fact, the basic objective of these type of citizen-centric application is that they can provide you some basic information which you may not get it by making use of instruments or by making use of the satellites. So basically, they bridge the gap between the available data, the data available, especially the real-time information you can capture, especially during disasters or even during COVID. Also, a lot of citizen-centric applications were used to capture the grassroots information. So basically, citizen science is diverse in nature. It can be used for various domains, and ultimately, there are many projects, like you can go to eBird is one of the project, then GBIF Anyway, Zoo Galaxy is there. So many other citizen-centric projects are there where people are trying to capture the information and they are providing those data sets to the user. Now, there could be different level of participation in a citizen science project. So according to the Heckley, there is a different 4 type of information which can be collected through the citizen science. Like for instance, the basic information is where you capture, you take the photograph, you put something, and that can be nothing but a crowdsourced information. Like you have OpenStreetMap. OSM is also one of the citizen-centric project where a lot of data is coming through the voluntarily geographic information. There is another second level of information where some level of interpretation is done by the citizen himself, and that can be contributed into a concept called distributed intelligence. Then above that, if the citizen is involved up to the analysis level, so that can be a participatory science where their involvement is there up to the problem definition, data collection, and some level of analysis. But when you talk about extreme citizen science, means the involvement of a citizen is right from the beginning till the end, means it is involved at the problem definition or conceptualization level, to the implementation level, to the analysis, and ultimately the results. So in all stages, that is called extreme citizen science, where the involvement is up to the maximum extent. So these different 4 type of level of citizen science is involved in the citizen science. So this is a classic example of COVID India, COVID-19 India.org, where let me tell you that there is the real-time information was captured by making use of this citizen science application. And in fact, the number of cases which was in fact reported, and they were directly go through the data quality check, and after that it was available on the Government of India portals. So these are some of the initiatives where the citizen science can, because here the time, or I would say near real time information, and it's not only the pandemic situation, during the disasters also, there was some disasters in Nepal as well as in Haiti. At that time, this particular citizen science applications was used. We have also developed certain turnkey solution by making use of citizen-centric application. I don't know whether you are aware, in India, there was a lot of the Clean India was one of the most important project which Government of India is working on. That is called Swachh Bharat Abhiyan. And in fact, for that, we developed a geospatial solution where citizen-centric information was the most important inputs. So for that, we developed this 2 mobile apps and 1 dashboard. And this, the Citizen app, was more for data collecting, because any citizen who happened to find a garbage location can directly take a photograph. It gets geocoded. You take the photograph, and then it directly goes to the dashboard, where the municipality, whose main objective is to clean the area, to provide all possible support. So that information directly goes to the municipality through the dashboard, and from that municipality, that dashboard helps municipality to assign that task to the person who is going to clean it. So that service app is another mobile app which is designed for the person who is cleaning that particular area. So that is more of worker level application. So here also, which vehicle you are assigning. So it's a total turnkey solution which was developed, and in fact it was implemented in in some of the districts in India, as well as some of the institutes also. So this is our total, and we got the patent that how this type of geospatial applications can be used for different purposes. Now we will move to the to another area called GeoHealth. I think this is an area where everybody has to really provide I think there is a lot of opportunities in this area. And in fact, the basic objective of GeoHealth is to develop the relationship between people, location, time, and health. And if you are able to link all those, or you are able to develop these relationships, then it is possible for you to really come up with some innovative solutions. So there are 2 aspects in GeoHealth. One is talks about the epidemiology, where you have the clustering approaches. You try to develop the relationship between the environmental variables and see that how the diffusion mapping can be thought out. Another part is talks about the healthcare, where the facilities, healthcare facilities, how the different available, what are the different facilities available, how they can be reoriented, or maybe you can identify new areas where the interventions are required. So these type of aspects can directly be taken care in the GeoHealth domain. So you have the data is an important, because the location data is always a difficulty in the field of GeoHealth. So there are softwares available where you can make use of either the existing GIS software, and even there are some softwares developed by UN or WHO, let us say, like Health Mapper and all. They provides you basic analysis to work on those data sets. So there are so many, like you have clustering algorithm, you have so many different type of algorithm which you can directly implement and ultimately come up with the maps which can be used by for the decision making. So these are some of the areas where I think this is a classic example of John Hopkins COVID-19 dashboard. Here it gives a good holistic dashboard where you can see that how many different type of cases are available, and then it also gives you a good visualization that how the entire different type of clusters are distributed all across, and even you can apply the drill down operation on these data sets. So the entire technology is being demonstrated in these type of application. So this is a very interesting article which I have published in the journal, that is review of geospatial technology for infectious disease surveillance use case on COVID-19. I think you can maybe you can visit this paper, and it will give you the holistic that how these type of technologies can be used. Like when you talk about contact tracing, you talk about clustering, you talk about different epidemiological modeling. Everything is being discussed in detail by making use of the geospatial technology. Big data, I don't think I will not spend much time, because already my colleague has covered. The most important part of big data is the veracity of the data, because basically you need to have the data quality of those data sets. The uncertainty of the data has to be ensured that you provide a good information which can be used directly by the user. So this is a classic example that how the Twitter analytics, you can see that if you have the social media available and you are able to model them, then you can see that how these visualizations can ultimately bring you information wherein you don't have to really see, but you can see that something is happening in that area and there is important event which is happening, and ultimately these type of applications can be developed. We have also developed one application on traffic monitoring using wireless sensor. In fact, the basic objective of this study was that how we are able to map the traffic congestion. Although I think if you are making use of Google Maps, people already know that these type of traffic congestions can be directly accessed by making use of Google Maps. But here we installed the sensor, and in fact it was based on Faraday law of induction, and in fact from that you can see that different type of response curves were observed among different type of vehicles, and according to the response curves you are able to identify the type of vehicle. Even you can even see that to what distance they are apart, and from that data you can develop a big data applications. You can monitor that in which area you have more traffic congestion at what time. All these studies can be developed, and this is a small case study which was pilot study which was developed by us, and in fact one can even explore some more applications which directly relates to this. Supply chain management is an area where a lot of in fact people did not realize that GIS can be used for supply chain management, and in fact if you see industry, they really look for these type of applications, that how GIS can be used to monitor the entire supply chain process. It varies from the raw material, how the raw material is supplied, processed, finished product, distribution, and the customer. So if the entire value chain can be directly modeled by making use of the geographical information system. Now I will take you to one of the study on Indian Bioresource Information Network. Maybe I can take a short pause and okay, there was some question I didn't look into. How do you manage accuracy of data coming from the people? Well, that's a very important and a valid question. In fact, the accuracies, now it all depends upon the data quality which is coming from this like for instance the one of the study I will show you here where we are trying to see that how the data quality can be assured. Maybe let me complete my presentation and then I will address your questions one by one. Okay, if it is agreeable to you all. So here I would like to give you small information that okay, there are few questions coming in between, so maybe let me finish my talk and then we'll come with the questions. Well, this is the Indian Bioresource Information Network. Here, basically, when we talk about bioresources, or let us say we talk about biodiversity, it is a very wide information, and in fact, it's always difficult to put all the data together. So whether you talk about plants, you talk about animals, you talk about chromosomes, you talk about so many different bioresource variety. So the challenge was that how we can collate all these data sets together and put them in a common platform. That is one. And the second thing is that because why it is important for the country like India, because it has got 3 or 4 hotspots in the entire world, which basically talks about the biodiversity, hotspot biodiversity. So it's really important for us to put them into, although there are so many other portals available in India which provide the species information, but this is totally unique because here the spatial data is also there, the species data, and also some other information. That is one, how we can put them together. And like I mentioned, the data quality measure. The first point which I mentioned was, in fact, the data quality, and it really put a lot of effort in really coming out of very high valued data sets. The standardization was done, enriching was done. Even we have captured some real-time data. I will share you a few slides on those. And then once you have these data sets available, there should be a mechanism to develop decision support system, or let us say OLAP applications. And then once those data sets are available, you have to really provide those platform in order to work on those lines. So this is a classic example of IBIN landscape. So basically here the platforms are there. We have data partners. We have plant data model. We have in fact come out with a new standard wherein you can integrate. And in fact, we have studied a lot of global standards and then developed our own data standard. Data quality was important part, modeling application, AI, MLDL, data analytics, data dissemination, citizen science, near real-time satellite telemetry, everything was part of this particular portal. So these are some of the data on bioresources, then some data on bacteria, animals, fungi, protozoa, chromosome. Different type of data is residing into this portal. So these are some of the different type of the species module which we have created. Maybe it may not be very interesting for you. So this is a classic example of that how we have first time tagged the cuckoo bird, which is considered to be the indicator of Indian monsoon. And we have installed this sensor and then captured the entire track of this particular bird. In fact, it was in Doon Valley, it went to Western Ghats, and then it has reached to the Africa, South Africa. So the entire satellite telemetry was done, and then we have tried to model this bird by making use of certain algorithms. So this is just a short information about this particular project. I thought that it will give you some broad idea that how these type of information can be collated. There is FOSS4G efforts. You might be aware that whatever applications I have talked about, whether you talk about 3D, whether you talk about web services, whether you talk about geo-health, whether you talk about traffic, whether you talk about biodiversity, everything you can make use of the open source software. So for all these stages, whether you talk about databases, whether you talk about web, whether you talk about simple GIS applications, all those operations can directly be taken care by making use of open source software. And in fact, there are a lot of advantages by making use of this FOSS4G. In fact, you can even contribute to different projects which are being executed under open source community. So now this is just a small, I just wanted to, in fact, give you a small that how we have evolved from 2000 to 2021, let us say, from evolution to recognition. People are talking about the data cubes, from data simple raw data to data cubes. The analysis ready data is talked about. The database model also, you are not limited to geo-relational model. You have talked about geodatabases, and now we are talking about OLAP, and even big data is also an important area where people are really looking at how the voluminous data can be handled. Web application architecture, we have cloud-based systems. We have moved from standalone system to a cloud-based system. The modeling capabilities has also evolved over a period of time. Earlier, people were only limited to empirical models. Now we are talking about process-based model, how we can make even a service-based models are also available. Data dissemination, you know that you are not limited with only the maps which you are showing through a map server, but also you have web services which provide the accessibility within certain standards. You have infrastructure, the cloud computing, you have interoperability, you have AI, MLDL, and big data. So things has evolved over a period of time, and now the efforts which were used in earlier times is much less because of the development with respect to the hardware, with respect to software, with respect to application. Everywhere people are making use of all this. So I think we are moving, we are changing our emphasis. We are not more into the data generation, rather we are more towards the knowledge as well as the wisdom which we are looking for. So that is the overall goal of our this thing. So in the end, I would like to say that the application of geoinformatics is limited only by the imagination of those who use it. So this important saying by Jack Dangermond. So we really have to explore a few this thing. So with this, I think I'm through with my lecture, and maybe I have a few questions.